Alright, so I'm back here at NT Performance Engines with my friend Matt Trevina. We're actually building, or we're looking at his engine today. We're not actually building it, are we? We're just having a bit of a look.
having a look through, yeah.
Yeah. I actually did a little post on the gearbox that he's using. He's using a Jericho 4-speed. I did a little post on Facebook, and I just mentioned that the 4-speed is going to be going onto an 800 horsepower 4AGE, like a 1.6, and the comment section blew up. So I thought, okay, I definitely have to make a video about this particular engine, and we'll also be making a video on his car. It's going to be a full series, so it's going to be like a long-term sort of thing.
Probably, yeah.
And yeah, well, he's doing this between customer engines, so it's not a full-time thing for him. So it's more of a hobby that he does on the side. So, but it is very interesting. It's going to be a very cool series, so stick around for this one.
So let's get into it. So I had a bit of time over the holiday break. Not that I had any holidays, but over the break to get it painted, and I finished porting all up the oil galleries and things. Yep. Yeah, so got a crankshaft bolted in. I'll spin it over.
So what kind of crankshaft are you using? Just a factory
Toyota 1.6 42mm journal crankshaft.
Yep.
I had this crankshaft. This build has sort of been, I've been piecing it together for, I don't know, 7 years now. This crankshaft has been in another engine. I used to swing off pretty hard, a little aspirated motor. This actually was that aspirated motor. And then when I built the turbo engine for it now, this block went to the side, and it was pretty good. So I decided to just put it to the side, collect parts for it, and over the years, as I've sort of got money from jobs here and there, I've sort of just put more money into this, and at the same time, you know, upgrading the car, the electronics, whatever I've done with the car. But when I had a little bit of extra money here and there, I'd purchase something for this. So rods, pistons, whatever it might be. Yeah, so this is where I'm at now. It's pretty basic actually. It's not too advanced. Just got ARP main studs fitted. Obviously the tunnels have been corrected. I've ported all the casting flash on the inside of the block, so it's all smoothed out everywhere. It's a 42mm journal oil squirter block, so it's a 7 rib. This particular one would have been a 20 valve block. Here I've done a crankcase vent, so I just drilled and tapped into the side of the crankcase, and a rear head drain for the 20 valve, which I can show you where I put the fitting for that. This particular block, I decided to not go to a specific size, let's say 0.5 mil or 1 mil oversize. I literally had next to no damage in the block, and I can show you this here. This is only 5/1000ths of an inch oversize, so 0.5 mil ends up being 20 thou. So I'm a quarter of half a mil.
Yep.
So
and you're doing that for strength more.
I'm doing that because I didn't want to remove any material from the bore.
Yep.
To try and keep as much strength as possible.
Yep.
And if you look here, you can see very fine marks just here, 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 and here. That's the only damage that I had when taking 5/1000ths of an inch off the block from factory. So I went to my mate Andrew McIntosh at Nitto. I worked with Nitto and CP and got a custom piston made for this. And we end up going with a 5 thou over standard piston. We went to a heavy duty cart like forging, so it's actually got more meat around the gudgeon pin, and yeah, pin force oilers. We went for a few options, anti-detonation rings around the top of the pistons. I can show you some of those videos of that.
Yeah, well, I'm sure we'll be seeing those in the future videos.
Yeah, definitely.
We'll definitely be coming back and having a look at have a good close look at the pistons.
Yeah, definitely. So some of the features about this one I've got for strength. Obviously, we went with a very small bore size to try and keep the size down, strength strong, so as much meat as we could in the block. It's also been concrete and resin filled, so I filled the water jacket with resin, and then over the top of the concrete, I filled it with concrete, and then over the top of that I topped it over just with some resin to seal in the concrete. And yeah, she's obviously, once you do that, that has to be done before you machine the block in the bores, because if you concrete, what happens is the concrete sets, it shrinks, the bores will replicate that. And if you've got a machined block and you pour concrete in after, the concrete will shrink those bores down. You're going to have problems.
Yeah, and
So-
something we were talking about earlier about the concreting a block was the concrete is only going to be on
Halfway,
the bottom
halfway
half
through the water
of
jacket.
block.
So if you look here, this is the water passage. I actually filled over it, so I've just
Yep.
ported this so the water can actually still travel in through the front of the block.
Yep.
So if you look at the water jacket comes down to about halfway down. It's actually easier to see on this side of the block. So this is the water jacket here. This is the entire length of it.
Yep.
My concrete probably comes up to about here.
Yep.
And what we're trying to achieve is strength in the block. There's no actual heat down the bottom of the cylinder, or less heat. The combustion is happening in the top.
Yep.
So most of your temperature is being absorbed into the cylinder head. So the idea is that as long as you have travel of water flow through the block, just in the top section, and then through the cylinder head, you should lose no thermal, there's no thermal downside to it. You're going to still transfer the same heat out.
And you're making the block a lot more sturdy.
Yeah, stronger.
You did give me a good example with a little WD-40 can, where we've got that can here somewhere.
Yeah. So if you get a can over this length and you actually press on it, you can actually sort of move that section of can. But if I was to say have this as complete solid steel, and then this section here above the halfway point was soft, if I push on that center, it can't actually move because it's actually solid through there. If I move up a bit, it's very difficult to move that section of, say, sleeve, which is replicated here. It's very difficult to move that if it's now half the length of height.
Yeah,
Sorry.
it's hollow.
Yeah.
Or not hollow, full of water, but the other half will be more solid with concrete.
Yeah. So it does definitely help. I'm not a big fan of sleeving blocks because you're then removing that. The sleeve doesn't actually become integral to the block. It's still a secondary piece.
Yep.
So if I was to bore this out for liners, you find that the block just loses all its strength.
Yeah.
So you start getting torsional twists of the block. And it will just start to crack all over the place.
And when we're thinking about 800 horsepower, that's 200 horsepower per cylinder.
Yes.
So yeah, you're gonna want to have to make it as sturdy as possible.
Yes.
Yeah.
So one of the other things is you've got in the 4A, you've got these steam holes which actually travel between the bores. These have actually been filled with resin. I don't actually need steam holes in this block. I run it on ethanol fuel, so we don't really have that heat. It's not the same as petrol. It doesn't burn as hot.
Yep.
Burns much cooler. And to make it even cooler again, you just pour more fuel in. Just run your fuel mixtures heavier, and she'll stay cooler. So you don't actually need. You can almost remove the cooling system. I mean, I've done it on a drift car that I look after, the Pro Sport Electrics Supra.
Yep.
Or the Game On Motorsports sponsored Supra.
Yep.
That car, we had cooling problems in Goulburn, and we actually lost a drive belt for the water pump just after we had rebuilt the engine. And as it was coming into the finals, we decided that after we lost the belt, we poached people from the pits were giving their belts. We couldn't make one fit. And we decided, I said to him, just don't worry about the belt, just send the car out with no water pump. And we ran that car for 4 laps of full power at Wakefield. We melted 2 sets of semi-slick tyres and we didn't overheat the engine. And all I'd done was add 20% of fuel trim. The thing was rich as hell, but it did not overheat with no water pump. Yep. So, that's the cooling benefits you can run from E85.
Yeah, cool. So one question.
Yeah.
With this engine, so this is going into your KE70.
Yep.
And you have filled the block with concrete and resin.
Yep.
So is this going to be a full-time drag motor or a full-time circuit car? Like, are you going to be able to, would someone be able to do that with a street car? Or is it?
Yeah, definitely. So I'll be street driving this too. So this will get driven on the street. Not a lot, but it will get driven. It's the idea for the car was to go. I wanted to run 10 seconds in the car on the quarter mile. And after speaking with a friend of mine from CS Engineering, Chris Spicer, he said, well, to go 10s, it's the same setup that I would do to go faster. What tyre do you want to run? I said, I haven't really looked into a tyre yet. He said, well, why don't we go for a specific tyre and we'll go for the record on that tyre. So the tyre that we selected was a Mickey Thompson ET Street 2 RS, and I believe the size is a 195/50/15. And that particular tyre has a record on it currently of 8.6. So that's the new record that we want to go for.
So you're trying to beat 8.6?
I think, yeah.
1.6 litre, 4 AGE, KD70.
Yes,
Yep.
So the current record is set with a Datsun. It has a 7 AGE in it, and it's an auto. I'm going to be doing it in a 1600 cc, sorry.
Yep.
With a manual transmission. So we'll see how it goes, but
yeah,
it will probably, without looking into it, it will probably be it's a pretty good feat to have a street registered car do an 8.6 quarter mile with a 1.6 litre. But again, we're going to try to get that.
Yep.
So the idea is the engine's going to make the power, or it's going to fly to bits trying. So
yeah, we're pushing the limits here.
Yeah.
So hopefully we can do it. If not, you're going to try it again.
That's racing.
Yeah. That's how it works.
I've already got an engine sort of that I'm planning for when this flies, when this flies to bits, that I'll be trying it for, which will be a combination 7A block with a billet 4A crankshaft, custom made from a company in the States, with an alloy rod, long rod conversion, and I think that's the engine that'll probably end up getting it. This one might not get there, but this will get me a lot of testing on the way.
But even with that 7A block, it'll be 1.6 litres.
Yes.
It won't be 1.8.
D-stroked. Yeah, D-stroked. Yeah, I'm looking for a long rod, so I'm looking for something that has the rod doesn't have to travel out too far from the centre line of the crankshaft, which is the issue with stroker motors, is they start to go out of square. So the bore by stroke starts going too far away from the bore diameter. The problem with that is the rod kicks out too far and it will snap, and then basically it wants to go out the side rather than up and down. So this particular block also has half-inch head stud conversion, one of my own conversions. So the block's been drilled and tapped for half-inch.
And you prefer half-inch because anything smaller, you're not really making a new thread. You want to...
Yes,
yeah.
So going from 10mm to 12mm, you'll find that there will be remnants of a thread in the block still. So if anyone's selling a 12mm stud conversion or anything like that, you'll actually find by the time you clear out all the old threads, there's still remnants of a thread in there. So going up to half-inch, you're almost 13mm. So yeah, basically the half-inch is the next size you go from 10mm.
Yep. So what kind of head gasket are you going to run?
So the head gasket system we're using, this is called a firing system, which uses a copper gasket, which is here.
Cool.
So this is the gasket system that I'll be running. It has no water holes currently drilled in it. I'll make those when the time comes. You can actually see that I've actually marked them out. So the tiny little scribe marks all over the place. Probably hard to make out.
Yeah, it's not always easy on camera, but I can kind of see it.
Yeah. What about here? You might be able to see that.
Yeah,
so you can
definitely
see
see
a couple
that.
of scribe marks there, yeah. So that combined with...
So do you have to prepare this gasket? Like, would you have to get a nice finish on it, or is this just the way
yeah,
it seals?
that gasket, currently is just a bit of a mess. This is the actual sealing ring itself. So this is made of a phosphorus bronze.
Yep.
Basically, they have a lip cut into them.
Oh yeah, okay. Yeah,
And
I
then
noticed that on the block. Yeah,
and on the deck
okay.
surface, they're actually grooved. They're cut into the block. And what happens is, this is a system that was almost 100% certain that this was poached from diesel technology. So the ring actually snaps into place. It's a pretty neat fit.
Yeah.
And then the gasket goes around that. Now on this there is protrusion. So this ring is 1 to 3 thou higher than the gasket. So if you actually measure this, if you measure the thickness of this with a micrometer, and then I measure the height of this off the deck face, you'll actually find that this is thicker than the copper gasket.
And that's so that when you torque the head down,
yes,
that crushes down.
Yeah,
and
this
seals.
crushes down into
Yep.
into the chamber of the cylinder head.
Yeah, right.
So these are obviously, you can see where the head gasket doesn't meet through the center. It's obviously because these rings butt up.
Yep. Okay.
Spot on next to each other.
Really cool.
So yeah, these are this system is used in drag cars, making 110 pounds of boost. It has been proven to work. It relies very heavily on the deck surface being machined perfectly flat, especially around here. And yeah, so basically they're neat fit, and like you say, it transfers heat really well from the block to the cylinder head via bronze. So that's the cylinder head gasket system. I will prepare this copper gasket as it will leak with unprepared. You prepare it with a 3-bond chemical.
Okay.
1207B340. So this is the stuff you would use. Basically, you cover the gasket in this. You do not cover the bronze ring, the fire ring.
Yep.
And that will seal the water passages and oil for the cylinder head, all that sort of stuff. And it is a reusable system. You can reuse this system. Most of the time when removing the head gasket, the copper gasket, you'll find that it gets damaged. It'll get bent and it actually gets a crease in it. Generally, you just buy a new one. They're very inexpensive. The fire rings are 100% reusable. Obviously, you can confirm that with measurements. It's very easy to just measure the inside of the fire ring here, which then of this to here, and that basically gives you a thickness of how far it is off the deck.
Yep.
Compare that against with a measurement of your gasket.
Right.
You can very quickly see if the rings are worn out and they need to be remade.
Yep. Pretty much all you want to make sure is that you've got that leeway to crush the fire rings.
Between 1 and 3 thou. Yeah.
Okay.
Yeah. The more you crush down on the ring, so if you have say 3 thou, you start to put too much pressure after that on the cylinder head. The cylinder head will actually start to over exaggerated. If this is how the cylinder head bolts down, the cylinder head will do this.
Right. Okay.
As the center is higher, and you essentially can crush them over. What will happen there is you'll either have the fire rings leak back and forward, or you'll have the cams start to bind up, because as you're moving the head like this, the tunnels start to go a bit out.
Right. Okay.
So one of the things that's always a good practice to do is have a completely bare cylinder head with no valve train in it whatsoever. Dummy fit the gasket as such. Fire rings in place, no glue. Bolt the head down, tension it all up with no valve train. Cams go in, spin your cam over. Very easy to check.
Yep.
That way it tells you, hey, my cam's turn, which means my cylinder head isn't bent out of shape. That way you can also pull down a test tension. So on these 1/2 inch systems, I'd be pulling down about 100 to 110 foot-pounds of tension.
Right.
Which is substantially larger than the 80 foot-pounds that a factory ARP gasket would have.
Yeah. Yeah.
ARP stud, sorry. So yeah, like you say, this all has to be trial fitted. There's no doubt about that. You cannot, when pushing an engine this hard, there's no question.
You can't leave any stone unturned. You have to check
definitely.
everything. Double check everything.
Yeah,
really.
with a system where you're running a factory size head stud, I mean that it's designed. People have this has been tested. This isn't something that someone hasn't just gone and done this. This is ARP has made the stud. It's been trial fitted into motors. It's been tested. They sell that as a product to the customer. I can't sell this to a customer without testing it myself. I know the system works because I've done it. But again,
there's no guarantees unless you actually put it through extensive testing.
Exactly.
Yeah.
So
Okay.
I would never promise to someone that I could do what I'm doing unless I've done it before.
Right.
So if someone said to me, hey, I want to make 600 horsepower in a 4A, I can get there because I've done it.
Yep.
This will be the next stage. If someone says I want an 800 horsepower arrangement, if this works, this is the package that I would sell them.
Yeah, cool.
Yeah.
So what about a billet block? Obviously there's a cost factor there.
Yeah.
Would you say if this couldn't hold together, would you ever consider going billet, or do you think you'd still persist with a cast iron block?
It's a hard one to say without actually getting there. If my problem lied in splitting the block, I'd be looking as to why. I'd want to know why I couldn't get there.
Mm-hmm.
So, I mean, I've come from a background where we built race engines for an industry, and we used to swing a lot of horsepower in big RB setups, and we used to split the bores, and first we thought it was because the concrete wasn't up high enough in the bore, so we kept going higher with the concrete until we were full of concrete, and we still found that our cylinders were actually getting ovalized, so the actual center of the bore was getting expanded, and we found that in the RB engine the crank angle sensor is actually optical, so it's a light passing through a platted disc with holes in it, And as the disc passes over, there's a light receiver on the opposite side. And basically, as the disc spins, the light is received as pulses. That's translated by the ECU into timing. What happens at high engine speed is the light becomes a singular light. So rather than pulses of light, it becomes a solid light. And what happens is you have oscillating timing, which is reflected into your engine. And when you want to hold, say, let's just give an example of 24 degrees of timing at 40 pounds of boost, the engine, the ECU can't interpret those signals, so it just starts randomly throwing numbers in there according to what it thinks at that time. So it might have 35 degrees of timing or 18 degrees of timing, and that oscillating timing would actually detonate the cylinder, and your cylinder pressure is oscillating very erratically, would actually explode the cylinder. So the cylinder would go out of round, we'd lose compression, we would blow the head gasket out, water from the cooling system would leak into the exhaust ports, crack the cylinder heads. We had all these issues, just back to one issue, which was the crank signal.
Yep.
So a very quick fix that was come up with a company was to mimic the Toyota 2JZ system, which is a reluctor, which is a crank speed wheel, which takes 12 tooth count off the crank directly. That gives crank position, and then a single tooth home on the exhaust to know where the cam timing is at.
Yep.
So that system is very accurate in gauging engine position and RPM. So you could hold beautiful timing the entire time. Once that system went onto the RB engines, they stopped having problems. They stopped splitting bores, they stopped lifting cylinder heads, and they made more power because you were able to hold specific timing wherever you wanted to in the map. So a very simple thing like a crank trigger system fixed block splitting, cylinder heads lifting, cracking the exhaust ports as water would leak into the hot exhaust ports from the cooling system and crack through the exhaust ports.
Yep.
So we were finding all these issues just from that one simple thing.
Yep.
So for me to go to a billet block, it would really require me to have exhausted all my reasons for this being a failure.
Yeah.
So
Okay.
yeah, so to reiterate, basically, it would have to take me the diagnosis and tear down of a failure to figure out why and how I can fix the problem. Going to a billet block would be something quite extreme, and it would be something I would consider, but again, I would want to have a lot of input into the design of that.
Yeah. So do you think if you had a problem like that trigger issue where you were detonating and splitting blocks and you did go to a billet block, that would still split the billet block? Or do
Yes.
you think, yeah.
Yes, it definitely does.
So you could
I've
go
seen
to
it
all the
happen.
trouble and then still have the same problem. So you really want to
Yeah, definitely.
go through everything before you went to that extreme. Okay.
100%.
Yep.
So I've seen guys go to billet blocks and still have issues with them.
Yep.
And it came back to simple tuning elements or timing factors, or for whatever reason. The term bulletproof when it comes to an engine, it doesn't matter how strong you make an engine, with the very few keystrokes you can destroy any engine catastrophically.
Yeah.
So there is no such thing as a bulletproof engine. The tune is 50% of the job. This is 50%, the tune is 50%. If either one of those is out of percentage, well, you've got an engine that's destined for failure.
Right.
So I can make this 90% stronger than the tune, but if the tune's only a 10% of what it could be, it's going to destroy this bulletproof engine.
Yeah. Right.
So, yeah. So this is just a little bit about the 4A block.
Can I touch it?
Of course.
Well, that'll be it for this video, guys. If you like the video, be sure to like, comment and subscribe. And if you'd like to see part 2, where Matt gives us a closer look at his 20 valve blacktop head, his mechanical fuel pump and his custom trigger system, hit that notification bell. Thanks, guys.